Hello students, good evening to all of you. So here I'm going to discuss about the electromagnetic induction chapter. So one of the important topic of this chapter, that is self-inductance of coils in series. So we have coils in series. We have to calculate the equivalent inductance of these coils. So we have these two coils. Two cases are there. One is non-interacting, other one is interacting case. So first we start with the non-interacting type case. So here we have two coils having a coefficient of self-inductance L1 and L2. So in this first case, students, we are taking the case of no interaction. It means that like no flux of one coil is being linked with another coil. So we can say that these coils are isolated with each other. So in that sense, the L equivalent for the combination is simply written as L1 plus L2. So there is no interaction, means no flux of one is being linked with the another coil. So in that case, your answer for the equivalent inductance will be L1 plus L2. Now let's move to the second possibility there. What is the second possibility? Second possibility is interacting coils. It means that the flux of one coil, like these two coils are in series. So if flux of these two coils get linked with each other, or in the case of interacting coil, let's suppose flux of one coils favor the other. It means that like the flow of current is in such a manner that flux of one coil basically linked with another coil, and another coil's flux also linked in the same sense. It means that flux of one is favoring the another also there. So in that sense, the voltage across one coil is simply written as L1 di by dt, that is that self induction there, and other one term is related to mutual inductance there. So in that case, the voltage induced across one coil is L1 di by dt. As you all know that the formula for the EMF is simply magnitude of EMF, simply E is equal to L di by dt in terms of self inductance, and in terms of mutual inductance it is M di by dt. So in that scenario, when flux of one coil is favoring the another coil, so in that sense, voltage across L1 is simply written as L1 di by dt plus M di by dt. Similarly, the voltage for the second coil is being written as L2 di by dt plus M di by dt. M is same for both the coils. So here L1, L2 are their coefficients of self inductance. So in that case, the total voltage across this combination of these two coils is simply written as V1 plus V2, and we know that we have the expression for V1 as well as V2. So we'll simply write the V1 plus V2, and this V1 V2 will come as L1 plus L2 plus 2M up into di by dt. So this is the expression for VAB across the combination. In that sense, this expression L1 plus L2 plus 2M is termed at the equivalent inductance. We are going to get the expression of equivalent inductance. So here, because of this interaction, the term 2M is being inserted in the expression of L1 plus L2. So here in this scenario, when coils are interacting, the expression for equivalent inductance is L1 plus L2 plus 2M. So where M is the coefficient of mutual induction. But in the case, let's suppose if these interacting coils, the current flow in such a manner that flux of one coil opposes the flux of another, we can say that the direction of flux of one is being in opposite direction to the flux of another coil. So in that sense, in the expression, in place of positive, we have to put the minus sign. So in that case, the L equivalent is simply written as L1 plus L2 minus 2M. So if flux of one coil is opposing the other, the answer for the L equivalent is L1 plus L2 minus 2M. Otherwise, formula is L1 plus L2 plus 2M. So these are the answers. Thank you very much.